Hello and welcome to this short presentation. Today I'm going to show you the process on how to create mix design or develop certain mix design and then eventually supply, monitor the strength and improve it, or let's say modify it or optimize it. So in this example, let's say I have to use 19 mm maximum size of aggregates. Specified strength is C50, slump is 190. I want to make it pumpable. So in the beginning, let's say I don't have standard deviation. So based on that automated equation, to get the required strength C60 or the target mean strength, I have to use 0.31 water cement ratio. And as for ACI, it suggests that I have to use at least 144 kg of water due to voids of the sand. So to do that, I have to increase this cement content. Let's say only for 65. Okay. Now, let's say we did some trials, both laboratory and plant trials, and we found out everything is complying to both fresh concrete properties and hardened concrete properties. So let's say we proceed to supply it in a certain client, and it so happened that we get a very good result, satisfactory result for the 3 consecutive strength tests, as well as for the strength test. So the coefficient of variation using the greater than 34.5 MPa graph, coefficient of variation is excellent, and within test coefficient of variation from very good to excellent, it suggests that we have a very high degree of quality control and we are very much confident with this running mix. So moving forward, we have to take at least 30 so that your standard deviation will be equate to I mean, you don't need to increase the standard deviation once you get a minimum 30. So we will take that last 30 and apply it to this graph to another presentation, which is statistical analysis with normal distribution curve and frequency histogram. I put some more parameters here, and based on this calculation, I found out that the standard deviation is 2.75. Now, using this 2.75, let's go back to our optimizer and apply this 2.75. So now, I just have to use 0.34 water cement ratio. That means I can actually reduce the cement content from 465 to 430. That much savings I did. But then you notice also that the margin now is very less, almost 4 MPa only. So if you are not confident with this due to some scenarios at the site, or if you want to be at safe side, let's go and use the manual input and say you are comfortable, let's say with 58 megapascal, like 8 MPa margin. So in this case, I have to increase a little bit of cement to compensate that water. So now it's 455. Still, I'm 10 kg less than the original mix design, which is 465. So let's look at the other parameters. So here the grading is okay. The pumpability graph is okay. Let's look for the coarse aggregate grading. It's okay. Fine aggregates is okay. And other parameters also are okay. So this is how we create mix design and improve and optimize. Thank you for watching.